A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi. We may have observed how street lights illuminate the darkness. In addition to this, we know how fans, mixers and many other devices are used to make our daily lives easier. All these devices require energy to work. We supply them with energy to meet our various needs. But what energy is used to make them work? Yes, it is electricity. Electricity is the fundamental aspect of our lives. But how is electricity actually made for domestic use? Don't you want to know how electricity is generated? Yes, we will answer all these questions in this lesson. We are already familiar with different types of magnets such as bar magnets, ring magnets and U-magnets. We have learned that a magnet attracts an iron rod. Likewise, a magnet can attract certain objects within its magnetic field. Such materials are called magnetic materials. The magnetic field is the region around a magnet in which the magnetic force due to the magnet can be detected. A magnetic field is completely filled with magnetic field lines. Here, a magnet is moved into or brought towards a solenoid. At that time, the light bulb which is connected to the solenoid glows. But the bulb doesn't glow while the magnet is kept stationary inside the solenoid. Why is it so? Before discussing the reason for this interesting phenomenon, let's get familiar with a device which is galvanometer. A galvanometer is an instrument which is used to detect and measure small electric currents in an electric circuit. We know that an ammeter is also used to measure electric current. But have you ever thought of the difference between these two? While the ammeter only shows the magnitude of electric current, the galvanometer shows both the direction and magnitude of the current. There is a needle in this device and along with it, we can also see readings on the left side of 0 as well as on the right side. If the galvanometer is connected to a source of current, the needle will deflect. The needle will be seen deflecting in opposite direction if the direction of the current is reversed. Thus, in this way, the galvanometer shows the direction of the current along with magnitude. Now, let's come back to our experiment. Substitute the bulb in the circuit with a galvanometer. When we move the magnet into the coil or out of the coil, the needle will deflect. The deflection of the needle of the galvanometer is similar to the one when the bulb glowed in the previous case. The deflection of the galvanometer needle indicates that the electricity is induced in the coil. A magnetic flux enters and leaves the conductor while moving the magnet into the solenoid. This phenomenon is called change in magnetic flux. Whenever a coil experiences a change in magnetic flux linked with the coil, an EMF is induced in the coil. This phenomenon, which was discovered by Michael Faraday, is called electromagnetic induction. Michael Faraday was a versatile genius who has proved his intelligence in physics and chemical sciences. In 1821, Faraday made his first discovery. He proved that if a wire is placed in a magnetic field and when the current flows through it, the wire will move. According to a series of experiments conducted in 1831, he discovered that electricity could be generated using magnetic force. Thus, he is known as the father of electricity. He also given his contributions to the field of chemistry. But the interesting thing is that he did not have a college education or a formal education. So, what is electromagnetic induction? We can easily define it as the production of an electromotive force across an electrical conductor in a changing magnetic field. Let's do another activity. Insert the north pole of a magnet into a solenoid. We can see that the needle of the galvanometer deflects to the right side. The deflection of the needle indicates that the current is induced in the coil in a direction similar to that of the coil. The galvanometer needle shows zero deflection when the magnet is kept stationary inside the solenoid. On withdrawing the magnet from the solenoid, the needle deflects in the opposite direction, indicating that the current is also induced in the opposite direction. What if we insert the south pole of a magnet instead of the north pole? Let's check. The galvanometer needle will deflect towards the left side while inserting it into the solenoid. This indicates that the current is in a direction opposite to that while introducing the north pole. So, from this, it is clear that the direction of induced current reverses when the direction of magnetic field changes or when the direction of motion changes. Now, let's introduce a magnet into a solenoid which has a lesser number of turns of coil. In this case, the deflection of the needle is a little, showing that current induced is feeble. We are repeating the activity by introducing the magnet into a solenoid having more number of turns of coil. The deflection of the galvanometer needle is more in this case, indicating that the current induced is more. Now, what if we introduce a stroke magnet into a solenoid with more number of turns? The deflection is seen more than the previous case, showing that the current induced is much more than the cases discussed above. Now, we are moving the stronger magnet into the above solenoid with a very high speed, and the galvanometer needle deflects very much, indicating that the induced current has increased again. Now, what happens if we keep the stroke magnet stationary and move the solenoid in and out? We can see that the deflection of the needle is very large compared to all the activities we have done before. This indicates that the current induced is higher on moving the solenoid faster. These activities helped us to arrive at some conclusions about the factors affecting the induced current. They are 1. Number of turns of the coiled conductor, 2. Strength of the magnet, and 3. The speed of motion of magnet or conductor. We have learned what electromagnetic induction is, how an EMF is induced in a coil, and what are the factors influencing the EMF induced in this way.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ ENCLAPS the Learning App.